Hello everyone, I have come with a very important video about graph algorithm. For learning graph algorithm, we have to learn the basic component of graph algorithm, and for experimental purpose I want to create this video in English. Graph algorithm. Graph is an abstract data structure. It is made by node and edge. It indicates different types of methods and their relations. And now we have to learn the component of graph. Component of okay, the main and basic component is node or vertex. V is the symbol of vertex. This is called the main element that indicates matter or dots. This is a node or vertex. And the second element and component is edge or ARC, and E is the symbol of edge or arcs. It indicates the connection or link between or among nodes. If these are two nodes and this is their connection, and this is called the edge. And the third component of a graph is weight. Some graph has values with it is, and this is called the weighted graph. If the connection of this is has value such as 10, and this will be an weighted graph. Okay, and now we have to learn the different types of graph. Graph is divided by many perspective, and we have to learn this. Different types of graph. Graph is defined many perspective. At first, depending on its structure base structure. Secondly, depending on its connection, and third is depending on its weight, and fourth is very important, depending on its special properties. Special properties. At first, we will try to learn the depending on its structure. Structure base. Depending on its structure, graph is defined by two types. Graph is defined by two types. That was undirected the example of undirected graph is if the two nodes and this is their connection. Here the direction is not particular of a is. Here you can see there is no direction of this graph. And second is directed graph. Two nodes and this is their connection. Here the direction is particular. It can be both or single side. It can be both or single direction. This is directed graph. And the second type is depending on its connection. Depending on its connection, graph is defined by two types. First is connected graph. Every node has minimum on edge. so it indicates the all nodes are connected with edge. Every node has minimum on edge. All nodes are connected um, with edge. This is called the connected graph. And second is disconnected graph. Here some node has no connection. It is a graph that has many connection, but this node is single. It has no connection. It is a disconnected graph. Third, depending on its weight. Depending on its weight, graph is divided by two types. That is weighted graph. Each has cost over weight. These are two nodes, and this is their connection, our relation, and this relation has weight or cost. Sustain. This is a weighted graph. And second is unweighted graph. Unweighted graph. Each has no weight or cost. This is only the relation or connection. Okay. And fourth is depending on its special properties. Depending on its special properties, graph is divided by four types. At first, cyclic graph. Second is acyclic graph. Third one is biparate graph. And fourth is complete graph. Complete graph. We will try to learn individually every time. At first, cyclic graph. We have guessed by its name that it has a cycle. It has minimum on loop if it is a graph, and we can see it has a loop or cycle. It has a loop or cycle, so it is called cyclic graph. Here is the cycle or loop. Second is acyclic graph. Acyclic graph means it has no cycle. It is known as tree. We have to learn this tree in data structure. It has no cycle. It has no cycle. This is called or known as tree data structure. And the third is biparate graph. Biparate graph. A graph can be divided into two parts, and the same part has no inner edge. If a graph is divided by two parts and same part has no inner connection, we can see the same part has no inner connection, and this has no inner connection. It is called the biparate graph. The fourth is complete graph. Complete graph, every node is connected with other all nodes. In complete graph, every node is connected with all other nodes. The example of a complete graph is if it is A, B and C. We can see that A is connected with C and B, and B is connected with C and A, and C is connected with A and B. So it is called the complete graph. And now we have to learn the graph represent representation. Graph is represented by two ways. First is adjacency matrix. Adjacency matrix. And second is adjacency list. At first we will try to learn adjacency matrix. It is n into m matrix. N into m matrix. Here 1 is indicate the connected and 0 is indicate 0 represent not connected. For example, A, B, C, D, E, F. On 0, here we can see E and A has no connection, B and E has a connection, E and C has a connection, and D and E has no connection. And the second row, A and F has a connection, B and F has no connection, C and F has a connection, and D and F has no connection. It takes low space and fast access. And second is adjacency list. Adjacency list. In adjacency list, every node has a list of its connected nodes. Here A is a list and A has a connection with B, C, D, and B has a connection with E, F, Z, and many more. It takes low space as adjacency matrix, but finding connection of a particular node takes long time. So adjacency matrix is better than adjacency list. Now we will try to learn the use of graph application. Shortest path finding or Google Map GPS routing. Dijkstra algorithm is used. Social network, Facebook, Twitter, graph traversal algorithms such as BFS and DFS is recommendation system. Netflix, Amazon, graph-based algorithm is used. Web crawling, Google search engine, BFS and DFS is used. Computer networks, router communication, and spanning tree (MST) is used. AI and machine learning, neural network, graph neural network (GNN) is used. So no more today. If you have any question, please feel free and ask me in comment, and wait for the next video. I will describe another algorithm in my next video. Thank you everyone.